Okay, so here's some exercises for that first objective. Being able to use a graph, picture of a graph, help us find some zeros of those polynomial functions. There's that guy, of course, probably getting a lot of leeches stuck to his body. Anyway, here is your first problem. Find all of the zeros of this function. It's a cubic polynomial. There's a picture of the graph. Maybe you can get something specifically from the picture, but first start with that rational zero theorem. List out your possibilities, and from that possibilities, what can I get from the graph to divide this out synthetically? Okay, give me a pause, and then come back and check your work. And we're back. Pretty tough, huh? Maybe, maybe not. You had a picture of the graph there to help you. So the tough thing about that is writing out all those possibilities. Yeah, here, take a look. So, ouch, there were 30 possibilities, 30 out of infinity. It's not too bad, but still 30 things to possibly try. Good thing that we have a picture. So looking at the picture, it was obvious that it definitely crosses that 1/2. 1/2 is a number that was in the list right here. So I know that that was something that was reasonable. So I synthetically divided by that, got 0 as the remainder. It definitely worked. So if I divide out a linear factor from a cubic, I'm left with a quadratic. So I just wrote the quadratic. I don't have to refer back to those possibilities anymore. I just factor that thing. So I divided it by 2, factored it as usual. That was pretty fun. And then listed out my final answers. So there's the 1/2, the original one that I found. And then we have 1/6, that's this point on the graph. And then -3/4, that point on the graph. Super fun. Why don't you try it one more time. Look at this one. This one's a quartic to the 4th power. So it should touch the x-axis maybe 4 times. It looks like right here it dips down below and then comes back up. Well, give it a try, see what you come up with. Man, oh man. Okay, so take a look at this. Right up at the top in purple, I listed out all of the possible rational zeros. Looking at my graph, comparing those to what I have in my graph, first of all, it looked like 1 across that -4. But I look back at my list, and I don't have a 4 in it, so that couldn't have been -4. All right, so the other one, the next one to it, looks like that's a -2. Oh, 2's in the list, so that's the one that I started with. So synthetically divide, got 0. Hey, that one worked. Okay, and then looking back at my list, oh yeah, before I move on, notice that now the constant term is 21. So it's not 42 anymore. I could go back up to my list, see everything that's marked down in red. None of those will work anymore. So 42 I crossed out, 14, 6, and 2, because none of those would go into 21. So all of those get crossed out. Now I've got a smaller list. Okay, so going back to the graph, so I know I can't get the -4 from the list, so it's one of these two, and it's in between a 1 and a 2. So looking at my numbers, what's between a 1 and a 2? That's the 3/2. So I checked the 3/2. It worked. Haha. I get a, oh man, I could have divided that by 2, couldn't I? I didn't. Oh well, maybe you didn't either. Quadratic. Use the quadratic formula on it, and here are the other two. It happens to be that they were irrational. Not only are they irrational, notice that they're conjugates. That's interesting, isn't it? Yes. So this means that one of them, say this one over here, must be -1 plus 2 squared root of 2. And this one that looks like it's at -4 must be -1 minus 2 squared root of 2. All right, I hope that that felt good to you. You know, up here. Anyway, see you in some more exercises.